This video is brought to you by Academy of Higher Learning. Hello and welcome to today's physics video on kinematic motion part 3. In this video, I will be going over the following graphs. Three graphs that I will cover are position time, velocity time, and acceleration time. So PT, VT, and AT. And the second thing I will cover are kinematic equations. So let's start with the graphs. The first one, position time. So in position time, this is a typical graph that you'll see. And uh, take note of this, that you need to put a direction to it. So in this case I've said north. So that means anything below it will be south. Anything negative is south therefore. So the information that is given, the first thing that it tells us is the position at any given time relative to the origin. So this will be the origin. However, it also tells us the slope. The slope of the graph, tells us the velocity. Now, if it's taking over an interval, it will be the average velocity, whereas if it's taken when as t equals 0, as limit t approaches 0, it'll be the instantaneous. So the first example is, what is the position at t equals 4 seconds? So the position is, it's very badly drawn, but in here it's minus 5 meters. Therefore, you can either write down minus 5, or the more appropriate way would be 5 meters, and in brackets s for south. So the second question is, what is the position at 8 seconds? And it's pretty much 0, therefore 0 meters. The second question is, well, that was part B. The second question is, what is the displacement between 2 to 6 seconds? So, as I've said in my first video, I believe, the displacement, delta D, equals the final position, or in this case will be position at 6 seconds, so P6 minus P2. And P6 is, running out of space, is 15 meters north, so it's plus 15, minus uh, the P2, which is plus 10 meters, giving us a final displacement of 5 meters. And make sure you put the brackets N for north. So 5 meters, the answer is 5 meters north of the origin. So that's the PD graph. The second graph is velocity versus time. Now, the velocity versus time graph tells us the velocity at a given time. The slope of the velocity time graph tells us the acceleration. So again, if it's at a specific point, so it'll be instantaneous, whereas if it's taken over an interval, it'll be average. The area underneath the curve tells us the displacement. So it tells us the displacement. And here are a couple of questions and examples. What is the velocity at t equals 3 seconds? So I've already labeled it down for you. At t equals 3, it's pretty much 6 meters per second north. And again, keep note of the direction. So it's at t equals 3 seconds, v equals 6 meters per second north. And the second question is, what is the total displacement at t equals 5 seconds? So like I said, the area underneath the curve tells us displacement. Therefore, just the displacement would be delta D equals pretty much the area of the triangle, which is 1/2 base times height. So 1/2 base is 5 times height, which is 10, and that gives us 25 meters. And again, with the notation, which will be north, since it's above 0, it's positive, I mean. And the third question is, what is the acceleration of the object? So the acceleration of the object is the slope, which is y2, acceleration for a, y2 minus y1 over x2 minus x1. So your basic slope equation, and y2 is 10 minus 0, and 5 x2 is and minus 0, which gives us 2 meters per second. Again, the direction is north because it's increasing. And final is the acceleration versus time, or AT graph. So the information given is it tells us the acceleration at a given time, and the area tells us the velocity. No, it doesn't tell us the velocity. It tells us the change in velocity. So change in velocity. So an example, what is the acceleration at t equals 8 seconds? And t equals 8 seconds, it's approximately right here, and it's 5. Therefore, it's, change the color here, it'll be 5 meters per second squared. And in this time it's not north, it's east. So I've changed the direction, so keep note of that. So what is the velocity at t equals 5 seconds? So I'm going to split this up first. So this is a1 and this is a2. And I'm going to say that at t equals 5 seconds, it's all going to be a1. And that is, so the velocity would be length times width, which is basically 5 times 10. 5 times 10, giving us 50 meters per second east. That's a 5. Now, at velocity at t equals 10 seconds, now these two, either you can, what you can do is add these two areas up, so v equals a1 plus a2, or you can say that this equals v, this equals v1, and we want to find v2, therefore it'll be v2 equals v1 plus a2. So a2 equals acceleration times time, so that will be length times width again, plus length LW, and that is 50 plus 5 times 5, because it's going to be, the time is 10 minus 5, I'm always skipping that, so giving us 50 plus 25, giving us final velocity of 75 meters per second, again direction wise east. So now since we're done with the graphs, let's start with the equations. So I've already written some of the equations. This should be familiar. Velocity is displacement over time, acceleration is velocity over time, and average velocity is v2 plus v1 over 2. And this is a different equation. Like, you can derive this equation if you know integration. So it's v1 v1t plus 1 half acceleration times t squared. So the other equation that you've noticed from the last page, it's this one. It's v2 equals v1 plus, in this case I said a2, but a2 is pretty much acceleration times time, therefore it's at. Now I'm going to rearrange it twice because you'll see why. So I'm going to rearrange it in here. So I'm going to rearrange it like this. v2 minus at equals v1. So I'll call this equation number 1. And the other arrangement that I'm going to do is I'm going to isolate the t. So it'll be v2 minus v1 all over a equals t. And I'm dropping the arrows, the vector symbols, because it's going to take way too long. Sorry about that. And I'm going to call this equation 3. So the first, so I'm going to sub in 3 into 1, or 1 into 3. So sub equation 1 into 3. And it'll be something like this. Delta D equals V1, which is V2 minus AT times T plus 1 half AT squared. So expand this and you'll get v2 t minus at squared plus 1 half at squared, and giving us the new equation of v2 t minus 1 half, if you collect like terms, at squared. So in this case, if you know the final speed, but not the initial speed, you can still solve the find the displacement. In the other and for the other equation, I'm going to first change the color, and I'm going to say sub the second equation into 3. So this equation will be something like this. So it's pretty much sub in the second equation. So that will be delta D equals V V1 times V2 minus V1, and I'm going to split the A, so it'll be 1 over A plus 1 half A, so it's a square, so V2 minus V1. Again, I'm going to split the A, take out the A from the bracket, so it'll be A squared. So as you can see that the A cancels out here, and next step I'm going to multiply both sides by 2A. So I'm just going to write here 2A multiply. So that's what I'm doing here. So I'll multiply the left side by 2A, so I'll get 2A delta D. If I multiply this side by 2A, I'll get 2 V1 V2 minus V1, and the A will cancel out, so there won't be any anymore. And if I multiply this by 2A, the half will go away and the last A will go away. So I'll just be left with V2 minus V1 squared. Next, I'll just isolate V2 minus V1, and I'll get I'll get V2 minus V1. I'll collect this, and I'll be left with 2V1 and this in bracket, so V2 minus V1. Next, collect like terms, so it'll be V2 minus V1, and it'll be V2 plus V1, which I'm gonna go to, and if we expand this, we'll get but if you use a binomial theorem distribution, we'll get V2 squared minus V1 squared, 2A delta D. So the next page, so last page it was 2A delta D equals V2 squared minus V1 squared. Bring the V1 to the other side, and you're left with, V1 squared plus 2A delta D equals V2 squared. Now this equation is really good since you don't need to factor, you don't need to know time. So this is a really good equation to know and to memorize. So thank you for watching the video, and hopefully you guys learned something, and you're welcome to visit www.aohl.info to view more videos like this. And this video was brought to you by Academy of Higher Learning. Bye. Have a good day.